Hey everyone, and welcome to the ARM microcontroller tutorial series. In this video I want to show you how I assemble my microcontroller breakout boards with a microcontroller on it. This is an SMT microcontroller. It has a very fine pitch, and one of the viewers stated that they find it very difficult to solder these microcontrollers on the board. In this video I'm going to show you how I go about this, and you may find that this is an easy process. You shouldn't have any problem if you do it in the steps that I show, but it does take a few pieces of equipment to do this. I want to thank everybody for their support. The book, the ARM Microcontroller Programming and Basic Circuit Building Volume 1, has been selling like crazy, and we cannot make enough of these ARM microcontroller kits, which includes one of these. I've been working hard in getting these done, so everybody has the opportunity to watch the videos as I'm making them and can follow along. If you don't have one of these boards, then you can get a breakout board in the links below. And also, if you get whatever microcontroller that you want to get that has the same number of pins as the breakout board that you're getting, you can follow this procedure to get the microcontroller soldered onto the breakout board. The pitch on these microcontrollers are pretty fine, so it is actually pretty difficult to do, but I have a technique that I use, and there literally are like probably 100 different ways to do this, but this is my way, and I want to show you how I do it. The stuff that I use to get the job done: I have solder paste. You don't actually need to have solder paste, but it's really helpful to have. I use solder paste so I can align the chip on the pads a little bit more easily, because the pads are raised and it's hard to get the pins on the pads without them falling off of the pads. And this gives a little bit of surface tension. And what I do is I preheat the board first with some hot air, and I spread the solder paste on. And I don't even care where it is, just as long as they're on some of the pins. And that's all I care about in the beginning. I use a vacuum pickup tool to place the microcontrollers on the board. You don't have to do this. I only started using a vacuum pickup tool recently, so it's not really that necessary. Probably best tool are magnifiers. I would not be able to do this without these magnifiers, just so I can make sure that the chip is aligned. I also use solder paste so I can flow the solder into the pads very nicely. And also the paste is actually, or the flux is actually meant to clean the surfaces of the metal so it adheres to it, but also helps with surface tension. And then solder wick. It'll get rid of bridges that will happen during this process. Bridges are when solder is bridged between two pins or more, actually. All those pins would be fused together, and then the chip would be unusable at that point. So you have to make sure those bridges are gone. And I use this wick, and then what I do is I spread it again to make sure all of the pins are evenly soldered. I sit really low in my chair, so my face can be as close to this area as possible. So I want to get everything ready that I'll need. Make sure my soldering iron is on. And I like to have a lot of paper towels as well. I use all of this equipment because I do like maybe 20 at a time. So it's not so, I do it in sort of a batch process. So I do one set of procedures, and then I'll do another set of procedures. All right, so first I'm going to preheat the board. I want to get everything ready before I do that. I'm going to get a few microcontrollers to start with. I'll start with 4 for now. I have my hot air set at 450 degrees. And I preheat the board just because the solder paste flows a little bit better. Then I just take one of the microcontrollers. I want to make sure that I orient it correctly. So the big circle is towards the skull and the little circle is actually the 1. Then I'm just going to get it kind of on top, and then I'm just going to let it fall. I sometimes use this to maneuver the chip onto the pads, but I'll also use just a little screwdriver. So what I'm doing is I'm just going to align each side until they're all aligned. And they look pretty good now. Yeah, that's good. So next I simply heat the chip. I go at a distance here just so I can sort of preheat it. And then I'll start to get closer in and aim at the legs. Because I don't have this on a hot surface, it's difficult for this to align itself. It's starting to melt now, and it's flowing into the pins. You can see there's a whole bunch of bridges, which is fine. This step I'm only trying to lock it in. I don't really care about bridges or anything like that right now. The board may be hot at this point. Okay, you can see all the bridges here, but I don't care about that because the next step I'm getting rid of all the bridges. Actually, it's a 2-step process. So what I'll do right now is I'll do like maybe 20 of these with all the bridges and the messy work. I know the microcontroller is aligned. That's the most important thing. It's the alignment that I'm trying to do here. I don't really care about how well it's soldered at this point. So now on to the next step. I'll do 20 of these, and then I'm going to be putting the flux on the pins. And I do this liberally. So my way of doing this, and I've found this to be the least messy way, is I'll just take some of the flux, I'll put some on a flathead screwdriver, and then I'll just like with peanut butter, just spread it on the... It's a little bit hot right now, so it's kind of melting already. I would normally put a lot more flux on this, but it's kind of hot, and like I said, I do about 20 of these, and the ones I do are in a cool state, but this will still work. Okay, and now I'm going to take my soldering iron, and this is the tip that I use for my soldering iron. It looks kind of like a chisel, and I'm able to distribute the heat a little bit better this way and also pick up any residual solder on this tip. There's also a cup tip that I also use, but I kind of like this one better. The cup tip, it has a little bit of a reservoir that can hold some of the solder that you'll need. So all I'm going to do is go across with the tip portion, and then the back portion I go back, just so they all have an even amount of solder. And you'll probably notice that there's maybe a solder bridge at the end here. Yep, there's like three pins, and I'll go back later, and actually I'll go back after I do this process. I'll go back and I'll use the wick to clean that up. It's good to use a ventilator when you're doing this, but that would create noise for this video, so I elected not to do it for this one board. I kind of like the smell, but I know it's not good for me. Okay, and you'll see that there's a lot of gunk there, and that's fine because I want to use some of that in the process of wicking the bridges. So on this one I have bridges on both ends. I'm just going to take my wick and I'm just going to hold it there for a very short time, and that one's gone. And that one's gone. And then I'll go over again, just making sure that the pins that I've wicked will have some solder on them. Alright, so let's see. Go get the other one. Those are gone. Just going to drag it across. The bridges are very easy to see as long as you're using some kind of magnification, unless your eyes are much better than mine. Okay, those are gone. And those are gone. Okay, no more bridges. And then I also test this, but first I want to clean up this board. Just get the excess off. And then I'll clean it with alcohol. It's okay. You can still see there's some left on there. So I'm gonna go ahead and get some alcohol and clean it up. I only use 99% alcohol, so there's no water that gets on the pads to oxidize them. I'll use either a Q-tip or the same napkin that I was using. So it is pretty clean already. You can see there's no bridges and it's a good solder. Now I go a step further and make sure I confirm all of these pins are correctly soldered. So I'm going to set it up in diode mode where it has a beep when there's a short. And what I'll do is I'll just walk through the pins to see if there's any shorts. So looks like 61 and 60 has a bridge. And 15 and 16 have a bridge. And 15 and 14. And this short tone doesn't mean there's a bridge. That means it's just internal circuitry, or like diode or transistor. This is the VSSA and the VDDA. You'll notice that some power pins do that, which is normal. Okay, so I need to check the 61 and 62, or is it 60 and 61? Yeah. And then 15, 14, and 13. 15, 16, 15, and 14. So I'm going to go ahead and get my solder wick. And I'm going to use some solder to, or I could use some flux maybe. I'll just do this process over again just to make sure that everything flows well. I don't have any bridges, I don't think, there. I don't see any. Then I'll do the same thing with 60 and 61. I just went across the whole thing just to make sure. So I'm going to go ahead and test it again. No bridge anymore. But I want to test this whole line again just because I did a resoldering on that whole side. Okay, so now 16 and 15. Good. 15 and 14, 13 and 12. Okay, so the next thing I do is I'll go for each pin. I'll just drag along because I know I don't have any. Shorts, so I can just take a pin and I can just drag it along. And if I hear a tone, I know that I have a good connection. Okay, they all checked out. This takes a little bit of time, but I am able to confirm that all pins are working. They're all connected correctly. There's no bridges going on and there's no shorts going on. So it ensures that you guys get the best product. But if you want to do it yourself, that's the process that I use. There's probably so many other different ways. The other way is to use some regular solder and a soldering iron and just put a little bit on a pin or two, just to lock the microcontroller down, and then you can drag the pins using some kind of flux like I just did. You can just drag over with that little bit of solder that you used on one pin. You can just drag that along. If you need some more, you can just put some on and then just drag it along, and it works really well with flux. Flux is your friend. I'm going to clean this one up. Let's see. I could probably do a little bit of a better job there. There you go. So that is the completed board, without the pins of course, but that's pretty easy to do. The way I put the pins on, I'll get another board like this, and then I'll put the pins in, like so. Just take some pliers and just bend those off real easily, and do the other row. just bend those off. And take 4 of them for the end. And then what I do is I take the board that I just soldered, and I'll put it right on top. So now that I'm ensuring that the pins are going to be perfectly perpendicular to the board. I usually put a couple long ones on the 63 and 64 and 49 and 46. So I'm going to remove those first. I just take the pin and I pull it out. Then I go to 46. I'll remove that pin. And then 49, I'll remove that one. Then I take these longer pins that I have, and I use these really awesome wrench plier combo thingy, and I'll just bring the pin out of its position and then just yank them out. It's hard to do this on film. Here we go. So that's one. So now I have all the long pins inserted. Now I can go ahead and start soldering all of the pins all the way around. You'll see that it actually takes less time to put this chip on than it does for me to solder all of these pins all the way around. It's really weird that the smoke from the flux inside the solder always goes straight to your face. My hand is getting too close, so it's not focusing right. So I'll try to do it like this. And now I'm just going to separate the two. And there you go. A microcontroller breakout board.